Hey Jacqueline, so this is my take on this exercise. I hope it helps and I hope that it's going to be okay. And I hope that you understand my weird English. I think we have to mix several things. So, for example, the change of volume from 15 milliliters to 20 milliliters, by the Archimedes principle, this means that the chain of volume is the volume of the chain itself, right? So we have a change of volume, a delta V, of 5 milliliters. So this is actually the volume of the chain. So we're going to put volume sub C, right? That's going to be the volume of the chain. And the mass of the chain is going to be 76.3 grams. Now, we're going to have to use the mass of the chain combined with the mass of the gold and the other metals and stuff like that. So we are going to make a system of equations, but we'll get there. We'll get there. All right, so we also have densities, and we have densities of gold and of different metals, all right, blah, 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 blah. In copper usually, all right, so the density of other metals is 9.7 and the density of gold is 19.3. All right, so we're going to use the formula of density. So you have to remember that density equals mass over volume, and we're going to use that in a little while. And so we have to start making our system of equations, all right, our equation system. And we can start with the mass, for example. So one of the equations that we could do is the mass of the gold used for the change plus all of the mass used in other metals. So let's put it m sub m, right, for metals, like the rest of the metals. It has to give us the total mass, right? But I mean, this m sub t, which is the total mass, we know that all of the mass of the chain is 76.3, right? So the sum of those masses, it has to be 76.3. There you go. Now we have to think how are we going to use the densities and stuff like that, right? So we can first of all think about the different densities of the metals. So we have, all right, I'm going to do this over here. You'll see why in a little bit. So the density of the gold plus the density of all the other materials. No, wait. Not the density. We're going to use the volume, all right? I'm sorry. So the volumes. All right, so the volume that is going to be used by all of the gold plus all of the volume that is going to be used by all of the metals. So we're going to use also the sub-index M for the metals. This has to give us the total volume. And this is the reason why I change, instead of the density, I change to the volume, because we do know what is the total volume of the chain, which is 5 milliliters, right? So that's why we want to use the volume. And also because if we change the subject in this equation of density, right? So, oh my God, I don't have enough space on this one thing. So, all right, let's do it over here and I'll erase it in a while. So density equals mass over volume. And we're going to change the subject and we're going to move this B to the other side, multiplying, right? And the density, we're going to pass it to the other side as a division. So it's going to be over here, right? This is going to be the change of subject. Now, why is this important? Because we actually know the mass of the, we don't know the mass of the different metals, of the gold and the other metals, but we know the density. Now, why is it that I wanted the relationship between the mass and the density? Because since you have to know what is the percentage of the change is gold by mass, all right? So we want equations that are going to work with mass. And on these equations that we already did, we already have a relationship with mass, right? So that is why I wanted to make another equation that has mass on it. So how are we going to do it? Well, the volume of the gold, you can see it from this equation, that volume equals mass over density. So we only have to change it, that this is going to mean that the volume of the gold, it should be the mass of the gold over the density of the gold. And it's going to be the same thing with the other metals, right? So instead of writing the volume of the metals, we know this relationship. So it's going to be the mass of the different metals over the density of the different metals. And remember, we know the density of both things, right? Because over here we have that the density of the gold is 19.3, and the density of the other things, right, that are blend are 9.7. So these are just numbers. These are not variables. So we are going to be able to make nice equation systems and everything. And this is going to equal the total volume, right? But we already know the total volume because we knew that it was 5 milliliters. So it is 5 milliliters, right? So we're going to change everything on the other side, right? So, and let's erase these things. All right, there we go. So we are going to have, with the second equation, it's going to be m sub g over the density of the gold, which is 19.3, plus the mass of the other metals divided by the density of the other metals, which is 9.7. And this have to be equal to the full volume, which is 5 milliliters. There you go. So now we have a system of equations, and you just have to solve for m sub g, I think. And what's the other thing that we have to do? All right, yeah. When you solve this, you're going to be able to find the percentage. I think you have to do maybe a little bit more things to find it in terms of percentage, but I think this is the right place to start. So hopefully there's like another answer in the group to see. I'm not really sure about this combined density, but I don't know. I haven't like thought about this like really thought about it. So hopefully somebody else can watch this and maybe say if they have another idea or if any of these things is not well thought about it, right? So, all right, good luck.